Okay, so today it's more about understanding what was happening here yesterday, which is if I run that again, Python train.py. So I was running, I'm just basically running 5 epochs, and then and in the output you can see that the loss sort of gets better over time across epochs, right? You can't see that within an epoch, but you can see that like if you plot the different epochs. But maybe, well, I just wanted to kind of double check here if in the train element, this is just it's just a loop. So the thing is enumerate train input, train output, right? So training loop for IDX XY in enumerate zip train input, train output, num train samples, exactly. In num samples, train ratio, input encoded. I'm using already 80%. Because what's happening is, so you can see here that it's like each color goes like lower and lower and lower and lower and lower, and the lila one is like at the bottom almost, right? What I'm trying to get though is understanding what's happening here with these the progress, because essentially we do a forward pass with x1, which is basically we take x because what we're doing is we're taking, I remember that what we're doing is we're breaking the sentence. So we're using that sentence to train it. We're breaking the sentence into like pairs of words, I believe, that it has and it kind of, it's like a sliding window. And then we use 80% of that to train. But essentially, that is why, of course, I was just having the wrong, of course, because essentially, so you do a forward pass. You're correcting, of course, you're not going to see that. This is stupid. Of course, you're not going to see, this was all caused by like a complete misunderstanding, like at the very beginning, where I was just plotting the epoch, like I was just plotting the laws just inside one epoch, where this makes absolutely no sense, because essentially each of these data points inside an epoch, right, is just you're making adjustments given a very specific input and output, right? So you have an input, calculate the output. That's like you have a word, let it print the next word, see how off you are from the actual value, correct for that, next pair, and you do that, right? But of course, after you've done the whole thing, you've kind of added corrections for everything, and so you end up in a state that, I guess that's what you should consider loss, is that last one in here. So to be honest, I think what we should be doing here is, which is what makes sense, which is basically, and that's not even, I'm not even sure that's the correct way to, yes it is, because essentially an epoch would be, you go through the entire training data set, right? So what is a AI? The definition of an epoch in a training with GD. I think that is the way it's defined, right? Guys, I'm expecting a call, so I might actually have to stop for a second, but let's see. One complete pass through the entire training data set. Yeah, of course. So, of course, you can't expect progress inside that, right? Because essentially, the fact that you've predicted, the fact that you've done something for your training data set, and then you're now looking at another example, it just doesn't mean that example will be improved by what you've learned in the past. I mean, maybe, but it doesn't necessarily have to be the case. Okay, so actually what we should be doing is we should just basically not like actually do the last loss. So backwards losses. So once you're done here, you just append the last loss. So you just append the last loss, right? You append the last loss. That's just stupid because loss. So losses. Loss series now. What's the code for that? Generate. Of losses. That's all I need. That's all I need. Just give me the code. Yep. Exactly. That's all I need. So you plot the losses. Yep. And if I now run this again, now I should be able to see the progress. Oh, why it's now why it's now doing it like this? Oh, Epoch 1. Okay. wait. I'm printing like these. How does these actually print in the same line? Does this is this what it's supposed to do? Epoch 1. So that's definitely like a I should print a line break. Is it because this F thing here? But it looks cool. So you're doing you're doing everything, and then and then that should now show me a nice looking nice. It's nice. It's very nice. It's very nice. It actually goes down. It goes down. It's beautiful. That's why inside, like, oh, this is just a fucking definition problem. This, how much can you get derailed by just like having a misconception? How much can you get derailed? This is crazy, but it helps actually. So now I understand. Now I understand now. So what's left now to do essentially is basically work on the other derivatives. Can you now give me the derivatives of these, right? So can you now give me in vanilla network pi? Can you now give me the code you calculate derivatives to the other, namely db2, dw1, and db1. Yeah. Ask. I hope it's gonna generate something, because that is then what I'm missing, right? So dw2. Stop. Can I stop it? Generate. Ugh. What the fuck? I just won the code. Generate. Can you give me the actual code? Oh. There you go. Okay. Okay, the output layer error. Oh, nice. That's nicely organized. So that's nicely books. That's nicely organized. So what am I doing? So Control C. And then we've got to that layer, and then updating the parameters. Not so sure if that's correct, but if I need to do this, whatever squeeze they're saying here, right? But we can check these in a second. So let's see. Then we can definitely like, oh, X. Oh, now X is missing, right? Of course, now X is missing. But now X basically backward. Where did I put it? As the first thing, X. I guess it's X1. I guess so. Let's see. Let's see if that's gonna break. Yes. Okay. X and learning rate. Train. Oh. Here. Okay, so GW says not gonna. Shapes. Okay, we're gonna have to. That's gonna require a bit of tinkering here. It definitely doesn't. This didn't play well, I think. But that's also not gonna solve it. I don't think that's gonna solve it because that just doesn't transpose it. Oh, wait. Self B2. So we might actually need that squeeze in here. Yeah. What does squeeze do? Okay, let's see if now it's better. It seems to, at least seems that kind of is working. So when we're now differentiating, so we're now basically doing the differentiation across all the other parameters, right? So that should give us a much better result, hopefully. I mean, just the outer layer was already doing a great job. Maybe that's kind of like, I don't know. It's a theory, right? Let's see. At least now we understand what's going on under the hood in terms of the epochs and whatnot. And then we could go ahead and test the model, of course, by just giving it, you know, a word of the same testing set, and then, or not the same, but like the award in the and then see what happens. But come on. But we'll do that in the next video. This has to be a short one, sadly. And come on, 80. Let's see. Let's hope that we don't see anything that's just like crappy right now. And then, I mean, we will still go and try to understand all these, right? These derivatives in here. But at the end of the day, who cares, right? So we understand now. We understand why these derivatives work the way they're supposed to work, right? So, and we know that you can, that it kind of makes sense. They are essentially, but we'll still do a recap video. Don't worry, we'll do a recap video. Okay, this seems to be done. Let's see what we get as an output. Whoa. Okay, I didn't expect that. I mean, could it be that too much training makes it worse? Squeeze kind of reduces the one dimensions. That's useful, actually. Feels very patchy though, but ASCII I can. Training. And worse loss. Short term, this can occur due to several reasons. Learning rates too high. Maybe. Inaccurate and inefficient gradient descent optimization. Issues related to the optimization algorithm simple in descent. Cost function landscape. Yeah. I guess the point is yeah. I could try and see if, let's do one last try and then say train. Let's do 10 epochs, see what happens, okay? And then we'll leave it there. But you know, I think that is you know, I guess that could happen. That can happen. Oh, it's not there anymore. I guess that can happen because once you get to a minimum, right? If there's no other way to go around. But I would say, wouldn't in first principles terms just not allow, like, shouldn't the algorithm itself not allow you to move, right? Because the gradient at some point is just zero, right? When you're at the minimum, or sort of close to zero. So why would it actually make you go up, right? Why would it make you go up? Like if you've gotten to the bottom, or if you've gotten to like a specific spot. Okay, I'm getting frozen. Yeah, it seems like. Is the browser not holding anymore? You know, at some point it's like if you're getting to a minimum, to a minimal point, why would these code that it just checks the derivative? The derivative is supposed to kind of tell you really. Those values are supposed to encode sort of the direction, right, where the minimal is. Okay, but maybe, I guess the point here is, if your learning rate is too high, even if that direction essentially, if that direction is just, of course, you're always going to get a direction, right? And that direction is going to be like you're just going to kind of go over it, right? So in other words, I don't know if I can I paint in here? Can I add color? Can I add something like a brush or something here? Let's say text, color source. No. Sorry, guys. Yes, I want to remove color source. I wanted to kind of like do a whiteboard or something like this. Scene, maybe, I don't know. What I mean is, you know, there is, if you're like at a local minima, that it's going to tell you direction, and then your learning rate is going to make you go up anyway, and then you go down again and up again. So I guess at some point, if you start like bouncing, it's kind of a sign that you're at the local minima. But let's see, at the minimum, let's see what happens now. So we've done all the, I don't know if I explained myself well enough, right? Yeah, you see that it's bouncing off. Yeah, exactly. So that's what's happening, is that you've gotten to the bottom, and then essentially the derivative is going to tell you direction, but because of your learning rate, you're going to kind of essentially pass through that minimum anyway, like the absolute point, and then just go to a region where the cost is a little higher. But then put into perspective, that only means then you're going to bounce again down, right? So you're bouncing again down, and then eventually you kind of stay here. So I guess you'll just keep bouncing. Okay, cool enough. Yeah, but that's nice, man. I mean, that's really cool. So I mean, okay, is this better than the other one? It seems a little smoother, definitely. It definitely seems a little smoother. Again, the amount of data that I'm using these with is just ridiculous, right? So, but now, I guess now, can I run the main now? I think I should be able to run the main now. And get the gentle breeze caress her what? The gentle breeze caress her Applejohn. Sorry. Oh. The gentle caress her face, this is supposed to say, right? Her myoplastic. I mean, what if I just say gentle? Okay. What if I just say gentle? Words. Gentle. It must be 5-word sentence. Or it just says one. Can I do that? Is it gonna work? No. Why? I thought like, okay, so you have to give it at least 5 words. Feeling a sense of tranquility. It still feels really random. I don't know why. So. Unfendered. Not bad. Yeah, I thought you were supposed to. Huh? Why didn't it just show something? Hello, how are you? Oh, I think We don't accept punctuation. How are you, my... Okay, whatever. That's awful. Stop. Feeling a sense of tranquility. Intramatrical. Okay, anyway. I gotta see if I can fix that. Maybe I can just, I'd like to see if I can just put a window size of 1. I don't know why this is a problem, to be honest. Window size is only used for the input size. Can I do 2 and then why is it not aligned? Window size 2. Okay, I don't know why it wouldn't allow me like lower dimensions. Feeling. Why does it have to be like 3 specifically? Okay, whatever. So I guess, what am I getting here? Oh, sorry, you guys are not seeing that. I'm very sorry. The gentle breeze caress her knoko. Makes a lot of sense, right? Makes a lot of sense. The gentle breeze caressed her educationist. Okay, it's giving me the same thing, but I thought it should give me something a little different. I don't know why. Peace card. Orbella. What is an orbella? Lexicalic. It's a little crazy, the words that it's using, right? Eye sleeve. Caress or eye sleeve. The gentle Falcunculus. What is it? What is the Falcunculus? Eastern Shrek teeth. Is that a bird? Okay. Okay. That's a good one. I'm gonna tweet these. Exactly. Okay. There you go. Have a good one, guys.